Okay, we're going to solve using the method of substitution, and we're going to check. Now, this question is far more complicated than the last question we have done. Okay. We have two equations. And remember, the goal is we want to set one equation equal to a variable. Right now, neither of the equations are equal to a variable. They're both set equal to 0. That doesn't quite work for us. We need an equation equal to a variable. So, this is very similar to your question 2 in your textbook. I'm going to look at these carefully and go, which equation will be easiest for me to set equal to a variable? If I quickly look at this one, well, there's a coefficient of 3 in front of a variable and a coefficient of 4 in front of y. Those are going to take a bit of work because I have to move terms over, and then I'll have to divide by these coefficients. It's a little extra work. In the first equation, I have a 2 in front of the y. Same deal. It's going to take a bit of work. But the first variable, x, has a 1 in front of it, or essentially it's just x by itself. So it'll be easiest if I take the first equation and set it equal to just x. That will be the least amount of work for myself. So I'm going to take equation 1. X minus 2y minus 2 equals 0. And because x is positive on this side of the equation, I'm actually just going to move the other terms to the other side. So we'll move negative 2y and negative 2 to the other side. We're going to get x is equal to positive 2y plus 2. Now obviously I didn't need to write that positive in, so essentially it's y is equal to 2y plus 2. I've now set the first equation equal to a variable, the variable being x. So we know x is equal to 2y plus 2. I can use that interchanging. So I now take this value, okay, and I'm going to replace the x, just the x, not the coefficient in front of it, with that value from the first equation. So we're going to take 2y plus 2 and replace x with it. So that means I now take equation 2. I'm going to write it out, 3. And it used to be an x there. Okay, you know what? I'll write it in this old way first, just so you can see the substitution. And this is what we mean by substituting. We're substituting a variable for an expression or a value. Oh, sorry. That zoomed in way farther than I thought it would. There we go. So we're going to replace that now. We're going to get 3, and I'll write in red what we replaced x with. Well, we replaced x with 2y plus 2. Then the old equation is still plus 4y minus 16 is equal to 0. I've substituted this value in for the x. That's what they mean by substitution. I now have to distribute my 3. 3 times 2y will give me 6y. 3 times 2 will give me 6. Plus 4y minus 16 is equal to 0. Now I only have one variable left, that one variable being the y. So we're going to solve for that variable y. We'll collect my like terms. 6y and 4y is going to give me 10y. And positive 6 and negative 16 will give me what? Negative 10. We're going to move the negative to the other side. 10y is equal to 10. Y is equal to what? 10 divided by 10, which is 1. Okay, so let's take a look at this whole thing. Okay? We have one answer. We have that y is equal to 1. So that's one of the coordinates. We know that was where the point of intersection is between those two lines. I now got to take that y value and plug it into either the first or the second equation. It doesn't actually matter once I have the value, so I plug it into either the first or the second. Since we substituted into the second, just for explanation's sake, we're going to substitute this one into the first. Okay? So the first question read, x minus 2y minus 2. Okay? X minus 2y minus 2 equals 0. So the first expression was x minus 2y minus 2 equals 0. Well, just like we substituted before, y is equal to 1, so I now replace the y in this equation with the number 1. X minus 2 times 1 minus 2 equals 0. 2 times 1 is 2, so we're going to get x minus 2 minus 2 equals 0. What's negative 2 minus 2? 4. And I move it over, x is equal to positive 4. So this is now the point of intersection of these two lines. The point of intersection, if we were to write it down, would be at 4 and 1. That's our x value. Whoops, sorry, I wrote those backwards. Oh no, I didn't. I lied. And that's our y. Okay? Our x and our y values.